Notice this is a compound inequality. It's two inequalities put together with the word or. So let's solve each inequality separately. And then we'll find or, which means the union. Let's solve the first inequality. I will subtract 5x from both sides. So I'll have the left side. I'll subtract 5x. And the right side, I'll subtract 5x. Notice I have 6x minus 5x, which is x, so that's x plus 1 is greater than 4. How do I finish solving this inequality? I will subtract 1 from both sides. Here's my left side. I'll subtract 1. Here's my right side. I will subtract 1. I'll have x greater than 4 minus 1, or 3. So I've solved my first inequality. Now let's solve the second inequality. I will subtract 1 from both sides. So I'll have 1 minus x minus 1 is greater than negative 4 minus 1. 1 minus 1 is 0. Don't forget, though, you have negative x is greater than negative 4 minus 1. That's negative 5. How do we finish solving? We will take the left side and divide by negative 1, and the right side and divide by negative 1. Because we're dividing by a negative number, we reverse the direction of our inequality symbol. And we have x less than 5. Don't forget this is or. Write this down. We're about to go to our number lines. Let's finish solving this compound inequality. I like to use 3 number lines when solving. Remember, this means union. So on the first number line, we'll shade all numbers greater than 3. So that will be a parenthesis at 3, and we'll shade to the right because we're shading all numbers greater than 3. On the second number line, we'll shade all numbers less than 5. So I'll draw a parenthesis at 5, and I'm shading all numbers less than 5. Now, this is union, so I want to now shade anything that's been, any number that's been shaded on this number line or on this number line. Can you see then that I would shade the entire number line, because between the two number lines everything's been shaded. So if I shade the entire number line, what would be my answer in interval notation? I have shaded from negative infinity to infinity. Every single real number is a solution to the original compound inequality.